In this video, I will explain what nuclear fusion is and how it works. You will learn why this reaction is so important for energy production and what challenges it poses. Nuclear fusion is a process in which two light atomic nuclei merge together. This creates a heavier nucleus and releases a large amount of energy. This process occurs, for example, in the Sun, where hydrogen nuclei fuse into helium nuclei. The energy produced in this process is what provides the light and heat we receive from the Sun. In nuclear fusion, the atomic nuclei must collide with very high energy. This is possible because the nuclei have positive charges and normally repel each other. To overcome this repulsion, extremely high temperatures and pressures are required. In the Sun, this energy is generated by the immense gravitational force that compresses the nuclei together. To achieve nuclear fusion on Earth, temperatures of several million degrees are required. These temperatures are necessary for the atomic nuclei to have enough energy to overcome the repulsive forces. Additionally, the pressure must be very high to keep the nuclei together. Creating these conditions is one of the biggest challenges in fusion research. In contrast to nuclear fission, where a heavy atomic nucleus is split into two smaller parts, nuclear fusion involves the merging of two light nuclei. Energy is also released during fission, but nuclear fusion releases even more energy. Furthermore, fusion produces less hazardous waste compared to fission. Nuclear fusion could represent an almost limitless and clean source of energy. It does not release harmful greenhouse gases that burden the environment. Additionally, fusion does not produce long-lived radioactive waste, as is the case with nuclear fission. This makes it a promising option for the future of energy production. A fusion reactor must generate the extremely high temperatures and pressures required for fusion. The reactor uses magnetic fields to control the plasma in which fusion occurs. The plasma consists of charged particles moving at high speeds. To enable fusion on Earth, these conditions must be maintained stably for extended periods of time. One of the biggest challenges in nuclear fusion is that it is very difficult to generate and maintain the necessary temperatures and pressures. Furthermore, the materials that make up the reactor must withstand extreme conditions. The energy required to initiate fusion is currently greater than the energy produced. These problems must be solved before nuclear fusion can be used as an energy source. In research, various fusion reactors are being built to test the technology. A well-known project is the ITER reactor in France, which aims to demonstrate nuclear fusion technology. In these experiments, the goal is to harness and control the energy produced by fusion. The focus is mainly on overcoming the technical challenges. It is expected that it will take several decades before nuclear fusion can be used as a viable energy source. Although research has made great progress, many technical hurdles remain. However, if successful, nuclear fusion would represent an almost inexhaustible and environmentally friendly energy source. Experts hope that significant progress will be made in the coming decades.